Okay, so I think it's probably about time for us to get started here. And again, as we're starting up, please feel free to still add your comments to the poll question for this week. I'm just going to take a look at what people have said so far. It would appear there are no responses at this point. Okay, so we've got at least something now. So thanks. Maybe now people feel guilty and will start filling in their responses. I'll put the poll link one more time here in the Zoom chat so you can also add things there. But yeah, as we go through these first few comments about last week's class, you can still be thinking if there's something you would like to add here, another comment you would like to make or something like that. The first thing here was a comment about being confused about the docstring. Yes, I think we didn't really have time to go through a nice example of creating a function with a docstring, but I can do that now just to show you an example of what that looks like. So I just have my CSC notebook instance open here, and I'm just going to create a new notebook for demonstration purposes. So the idea with a docstring is that it provides you with some sort of natural human language description of how a function or some script file works. So we could create some example function here. I'm not feeling super creative this morning, but we could go with something like, how about +3 that takes a number as its parameter. So our +3 function, we'll define again with a def statement, the name of the function, and then the parameter it takes. I'm going to add my docstring here in the line that immediately follows the function's definition. So this is indented as it should be part of the function. And this should be a description of what my function does. And oftentimes you can have a single line docstring, and that's perfectly fine. That's enough documentation for a simple function to explain what it does. So in our case here, we will just say adds 3 to any input number. And in this instance, I think that's sufficient. It's sometimes the case if you have multiple parameters, if you have optional values, if you have a little bit more complicated function, that you might have multi-line docstrings. But for the majority of the cases that I'm dealing with when I'm normally writing my own code, they're pretty simple functions, and I just make a simple one-line docstring as a result that tells me what the function does. In case I forget what the name of the function tells me, then I have this docstring I can rely on, and I'll show you that in just a second. So all this is going to do is just return number +3. I don't know that there's any real world use of a function like this, but whatever, we have it now. So I'll do Shift-Enter to define the function. Remember that this just creates the instance and provides us with the possibility to use the function. And if I was to do now, for instance, help +3, when I run this, it will find that there is some help available for a function called +3, and it just then prints out the name in which the function is defined, so +3 number, and then adds 3 to any number, the docstring that we had added there. If we had a little bit more detail, we could have things like a description of what the expected parameters would be. And I think this is covered a bit in the lesson in the example about the good coding practices. But we could have something like even within our docstring, something like parameters. And we could then add underneath here number. and this should be any numerical value. And we could even say int or float, although I would hope that not float, but float. So you could have, additional descriptions, and I think there are some stylistic things that are shown in the good coding practice for this week that will help organize your Docstring to make it easy to read and easy to understand. But something like this will allow us then, when we get help on our function, to see a little bit more about how the function's expected to work. And here we can see we have this parameter called number, and it's expected to be a numerical value. So it's essentially just meant to give you additional information about how to use the function. Of course, now if I use +3 with any number that I want to put in there, I just get a return value of 43. So the Docstring doesn't do anything in terms of the function's output. It's basically just documentation to help make the function easier to use. So yeah, I know last week we got pretty busy with a lot of things about functions, and to add in discussion of Docstring, we just didn't really feel like we had enough time for it. So we left it as sort of an additional topic to read over when you had some time. So hopefully that provides a little bit of information about the Docstring. I guess there's one other Docstring related comment here. So Docstring was new. Don't really get the difference between that and a comment. Yeah, I think the difference here is that inside the function, I could add a comment like an inline comment here saying add 3 to the input number. We'll change our function a little bit so that now it says number, or, well, whatever, number equals number plus 3, and then we can just return number. When I do this inline comment is something it's only going to mean something to me as the one writing the function. This won't be visible to anyone who tries to use the function or to look up the help on the function. So if I just define the function again with this modification here, when I do help on +3, I get the same output I had before, which is only the output that comes from the Docstring itself. So that is, I think, the big difference. This tells us something, for instance, if you want to explain to someone who might look at the code for the function, how it's working, you could have things like inline comments. But the vast majority of the time, users won't be going and looking at the code. Even you yourself may not always go and look at the code for how a function works, but instead you might go, yeah, how do I use this again? What's the expected input value? And this is where the Docstring can be helpful, because you can just simply do help and then the function name, and then that will tell you as a reminder how to use the function. And this is basically the same way that things like when we do help print, this is the built-in function print, and it's Docstring. So this tells you how the print function is intended to be called and used. And so this is a useful thing to include in functions so that the users can figure out how they're supposed to work. Oops. So I think we need more practice with these and other things we've learned. I assume that means functions and script files. Are there any extra exercises available, or maybe some website made by somebody else? There are some other websites, I think even on the course page in the resources here for useful books and sites. There are some Python tutorials, and perhaps one of these two would have some other opportunities if you want to practice with functions and things like that. I think Code Academy and the Software Carpentry Group's materials are pretty good, although a lot of what we're doing is based in some sense or loosely on the Software Carpentry Group's materials. You could go and potentially find some additional opportunities to practice with one of those 2 pages. Beyond that, I think you can Google around and see. I don't have something else myself that's coming to mind, and I don't know, Hovard, if you have any ideas of additional places to practice. We try to provide some extra problems in the exercises when possible, but of course, that all is basically like if we have extra time to create extra problems. And so, as you might imagine, there's not a ton of the extra problems. So, yeah, and it feels like code is hard to read when full of docstring and comments. Yeah, so that's true. I mean, this is something actually in terms of coding philosophy. There are some people who think that adding too many comments is a bad thing because it does make breaks up the code sometimes and makes it harder to read. I think there is a sort of idea out there that if you write really clean and nice code, it should be easy enough to understand without a need for comments. But that applies to people who are more experienced with programming than most of us in the course would be. So for us, I think at the moment, the most useful thing is to sort of take the opportunity to add these inline comments as you're working. And with those inline comments, as you explain what you're doing kind of step by step, I think it helps you to be thinking a bit more about the code that you're writing. So it's a sort of measure for learning. And it's a good practice in a sense. I still tend to, when I share code with someone, make sure that I have comments in there that explain, maybe not what every line does, but at least explain the general idea for most parts of the code. So that is something to have in mind. But I do understand that the docstring is something you really should include. If it's even just a single line, that's a good thing to do. And the inline comments, as you get more experience, maybe you can start reducing how many inline comments you have, but they're still useful. I still like to, even do things like have a comment that just says, import the modules we need or whatever, just to help myself in organizing how I'm looking at the code. So, yeah, I think that's all I'm seeing for comments on lesson 4. So thanks to those of you who filled in the comments. And if there's anything else, you can always ask in the Zoom chat as we go along through today's lesson, and we can come back and answer any questions along the way. Now, a couple things before we get to getting started with the lesson for this week. One is just a couple comments about the exercises. Some of you will have noticed that we finally did the automated grading of exercise 2. Apologies about that. There was, some updates to a few different packages that changed the way the automated grader was working, and I had to kind of figure out how to get it working again. Finally did that earlier this week and have now auto-graded exercise 2, and most probably will auto-grade exercise 3 today. So you'll have preliminary feedback about both of those. I should note that I got about 3 or 4 messages right after the first, so exercise 2, when it was auto-graded, from people that were worried about the score. Yeah, it's important to note that the score that's given by the auto-grader is a preliminary score. It's based on whether or not you pass the additional tests that are used in the automated grading system for the exercises. And it does happen that there are situations where for one reason or another, the auto-grader fails, even though you have the correct answer. So just to give you an example, if you have some variable, like we're going to work this week with these things called data frames. They're kind of like fancy Python lists. If they're the wrong size, but have all the right values in it, sometimes the automated grading will fail because it's expecting something of a certain size. And there are other situations where your answer deviates just enough from what's expected that the automated grader gets sees it as incorrect and then gives you 0 points, for instance. Don't panic if that's the case, because what happens is that after the automated grader has finished running, the course assistants then manually review the preliminary points granted by the auto grader and just make sure that, if there were points that were deducted, that they were actually deducted for an incorrect answer and not because the auto grader failed. If you're wondering, why have an automated grader if people have to look at this a second time anyway, the point is that in the cases where people get all the points, we basically know that you've got the right answer and we don't have to go back and review those problems. So it kind of cuts down on how much time we need to spend reviewing correct answers, and then allows the course assistants to focus on reviewing and giving feedback on answers where you maybe didn't get the full points. So that will be happening. What you'll see in your notebook files, like in the readme.md file, you'll get the preliminary score from the auto grader, and then the course assistant will edit that readme file to supplement what was granted by the auto grader and possibly change the score. So you'll notice, for instance, with exercise 2, that you could only get 8 out of 10 points from the auto graded anyway, because there were 2 manually graded answers where you had something to type in, and the course assistants have to review those by hand. So if there's any questions about the automated grading and the sort of preliminary grades, maybe it's good to put them in the Slack channel for whatever week the exercise is from. That might be a helpful way just to organize things there, but you can definitely ask questions in Slack or in Zoom if you have them. The one other thing I wanted to note about the exercises, and I've added this as a note in this week's exercise, is there were about 5 or so exercises where the auto grader failed because someone had changed the cell type. So from markdown to code, or from code to markdown for an existing cell in the exercise. Please don't do that, because it just basically the auto grader gets confused. It expects to see a code cell and it gets marked down, or vice versa. And it actually won't complete grading. It just fails and errors out. So you're welcome to add new cells, and you can add new cells and make them whatever type you want, but please don't change the existing cell types from code to markdown or markdown to code. It's better if you want to, for instance, use an extra markdown cell for describing something. It's better to maybe just add a new cell somewhere, and then you can make it whatever type you want. That's not a problem. And the auto grader will just kind of ignore any new cells that are added. But yeah, changing the cell types causes it problems. So please don't do that. There was a question here about where do we find the grades. I think that's about the exercises. So let me show you here. I have my exercise 2, which I created, but I don't think I did anything to. I don't think I modified this once I created it. So if you go to one of your exercises, it's like whatever your personal exercise repository is, or because you're working in pairs, whoever the driver was, it would be their exercise repository. What you'll see if you look in the file that's shown here, this is the README file, is down at the bottom. There will be this extra thing that's been added that says, exercise 2 grade and feedback, or exercise whatever grade and feedback, this many out of 10 points. So I got a 0 out of 10. No surprise, I didn't do anything. So, and then it lists the grader. So in this case, right now it says grader bot, which is the automated grader thing that we use. And you'll notice it also says here, awaiting review by a course grader. So that means that this is a preliminary grade. So once Brian or Alex would take a look at it, they would then replace the grader bot with their name, and then they may adjust these problem scores as well, and possibly add some feedback comments. So that's where the information on the course or on the grades for the exercises will be in your README file. I think at some point, once we have graded a few more of the exercises, we can also, I think, find a way to, I think last year we had some way that we were sharing the kind of exercise scores for everyone for each week in a little spreadsheet or something like that. I don't remember exactly how that worked, but I can try and see if we can figure out how we did that last year. I think one of the course assistants was responsible for having some spreadsheet where you could see all of your exercise scores, which I do understand would be helpful. But yeah, for the moment, you can look in the readme.md file of the driver for the exercise for that week. Okay, let's just go back here. One other note about the exercises is just that this week with exercise 5, I think things get a little bit more well, I think the exercise this week is a little bit more challenging than the previous weeks. So if you haven't already, you may think about reserving yourself a time in the exercise session on Thursday or Friday to come in person. You can sign up in the spreadsheet that is linked in Slack in the week 5 channel. And you may just benefit from making yourself a reservation and going now, just so that you don't feel like you are pressed for time when it comes closer to the time to turn in the exercise next week on Wednesday. That's just a reminder. Okay, so there's at least one person here in chat saying that they don't have any feedback on the exercise. If you were not the driver for the exercise for that week, you would not have any feedback. But if you were the driver and you were expecting to have feedback, maybe you should let us know in Slack, and we can check and see why your exercise didn't get graded. Normally what happens is we just make a list of all of the GitHub usernames who are the drivers for that week. So it's possible there was a mistake and we just missed grading someone. So yeah, if you're expecting to see a grade for your exercise and you were the driver for week 2, then let us know in Slack, and we will we'll go back and redo the grading for your exercise. Any questions at this point? Okay, so the other thing we had this week is you did fill in, or at least a number of you filled in our midterm feedback. I have looked through things preliminarily, but I didn't have quite as much time this morning as I was thinking to go through everything and fill in all of the feedback in a summary. So I will maybe post in Slack the feedback summary once that's done, just so that you can see what everyone's comments were. It's always nice to have a sense of how other people are feeling about the course. But I can answer a few questions at the moment. So the feedback, the survey that we had to do was, maybe I can even show the survey here. So I think 28 people filled it out, which is pretty good. We've done a little bit better in the past with the sort of response rate, but I do understand, there's probably online stuff fatigue at this point. So totally understandable. And what we have in the feedback here was essentially a few open questions here. So is the pace of the lessons too fast, too slow, or about right? And I did look through maybe the first 4 or 5 of the feedback questions. For that one, what we had was that most people felt it was about right to maybe slightly fast. And I think that's pretty much on par with how things have been in years past. There was a request that maybe a little bit more time could be given for some demonstrations. So like when you're asked maybe to do these little coding tasks during class, that we could give you a little bit more time. And yeah, we do understand it's always a balance for us. It's a bit challenging to maintain between spending too much time on those things and losing time that we could be teaching. I'm sort of like introducing new material versus the time that we have in the class as a total. The one other thing that was noted here was that there are a few people who are basically only watching the lesson videos, and this is something that if you feel the class and the sort of lectures themselves are a bit fast-paced, you can always go back and rewatch. You can always go back and rewatch the feedback that you have, or sorry, the lesson videos from the previous lesson. So we put them online. Normally it's about a day after the lesson, and you can go back, and if there's something that was confusing, please go and take a look at the lesson video and see. It may help just to review it once that way, and maybe clarify things. Was the content of the lessons too simple, too difficult, or about right? Again, here most people said it was about right. It's typically the case that students who have some previous coding experience find it to be a little simple. Those who are new maybe finding it to be a bit challenging. And it was noted by a few people that the content in the lessons is significantly easier than the exercises. That's partially by design. I mean, we're introducing it to you the first time, so we want things to be somewhat more accessible. But yeah, we do understand. And there was also a comment that more examples would be helpful. And yeah, we again understand that it's a challenge for us to try to find the right balance with introducing something and how many examples to show. Content of the exercises, I also looked this one through. So some people who are new to coding were saying that this is feeling like the exercises are a bit too difficult, that they're being pushed right to the edge of what they can do. And again, that is somewhat similar. People who have coding experience in some cases say that the exercises are too easy. So we're trying to sort of maintain the balance that we don't want those who are new to feel that they can't do them. But we also want you to be challenged in a good way. There was a comment or two that were people noting that they felt the exercises were too hard to do on their own, but with their partner, they were able to do it, which is also maybe a good thing. I think in some sense, the exercises themselves are a bit easier to manage when everything is happening on campus. So like if you're coming to the exercise sessions in person, I think that makes it easier to do the exercises because sometimes you just need one or two questions answered and everything is good. But yeah, that's again, it was noted here about the exercises that they're significantly harder than the material we learned during the lessons. And as mentioned, like that's partially by design. We want to introduce something in the lessons and then really force you to think about it when you work on it in the exercises. I also looked a little at the things that were sort of most and least useful aspects of the course. So the website was one of the things that was noted as good, although someone specifically mentioned that the material about the functions and the namespace was less well written than much of the material on the page. And yeah, that is something that was added new this year. And the examples probably need to be refined a little bit more to fit within the style of the rest of the lesson. But yeah, I hope the topic itself was useful to learn about. Slack and some of the other tech stuff, the kind of tools that we're using in the course were noted as useful things. And just overall, the kind of design of the course was noted by several people as being beneficial. Things that were, well, I guess also noted was the pair programming as something that was useful. And that came up in quite a few comments. So that was really nice to see that people are feeling like being paired up with someone is not a detriment, maybe for once. So yeah, so that's nice. And things that were least helpful, I think a lot of people left this blank or said that there weren't many things that they felt were not useful. Some who had more experience felt that the pace was a bit slow, or some felt the exercises, like they took the opportunity to note the exercises are too difficult. But overall, I think the comments were pretty much in line with what we've seen in years past. And we do introduce a lot of different websites and tools, and that can sometimes feel a little bit overwhelming at first. And there was a comment about the exercises, like we tell you not to copy paste things in the exercises, that there's a lot of strict rules. That is a large part based on us trying to use an automated grading system. So we would like to give you a little bit more flexibility, and we do that with some of the extra problems, but for the regular exercise questions, we do have, unfortunately, some strict rules that you're needing to follow to not cause the autograder to fail. So the other questions that are in here, like comments about improving the course, things like that, I will go through those and perhaps summarize that, and I'll send a link then in Slack where you can go to the course page and see the summary of the feedback. I won't include it, for instance, on the course page as one of the links over here. I'll just send you a direct link to it so that you can go and see the feedback for this year. And I may possibly, when Håvard is doing his lesson, I may be able to compile the feedback then, but it may not happen today during class. Might have to be sometime this evening. Any questions at this point? Taking a bit of time from this morning's lesson, but I think this is a good thing to just get some feedback about how things are going. So appreciate those of you who shared your thoughts. Any other comments or anything in chat? I'm not seeing any. Okay. All right. Well, in the interest of time, we're going to jump here over to our lesson introduction, our overview for this week. And this week, what we're going to be focusing on is interacting with data files and learning a new Python library called pandas. And so I'll tell you a little bit about what pandas does, and then Håvard will take you through the first part of the pandas lesson before we have our break, and then we'll continue with a little bit more about pandas and then the intro to the exercise. But the basic idea is that pandas is going to allow us to interact with our data files, read them in, and manipulate and do some data analysis using Python. And it's a very nicely designed and somewhat intuitive way to interact with data. So by the end of the lesson, the thought would be that you'd be able to read and write files or read and write files using pandas, read in and explore your data with the pandas library, and do some kind of simple data analysis tasks. We'll continue actually next week with pandas as well, doing a little bit more advanced things. And then in week 7, we switch to focusing on visualization of data. So that's where we're going. What is pandas? Well, it's a modern and powerful library for interacting with data files, doing data analysis in Python. And it's building on top of a number of other existing Python libraries, such as NumPy and Matplotlib, that are kind of under the hood in pandas. And pandas is sort of a high-end library that makes it easy to use things that are available from these other packages, and more intuitively, perhaps, than you would by the packages themselves. So there's a few things about pandas that are notable. One is that there's a couple data structures. We'll introduce those at the beginning of the next lesson, but there's a thing called a data frame and a thing called a series in pandas that are structures that allow you to work with data that would normally be like in a spreadsheet in a very easy way. So there'll be things like names for the columns and names for the rows that you can give meaningful names, not just index values like 0, 1, 2, 3, but actually meaningful values there. And then instead of having lists where each list has, maybe a set of values, in a data frame, you can have many different rows and columns, and each of them can be named, which obviously makes it easier to interact with. It also combines, as mentioned, functionalities from a lot of other Python things that are used under the hood, like NumPy, Matplotlib, and so on, SciPy. They're all part of what you can do in pandas, but pandas makes it easy to use all of these and combines them in a way that you don't really know you're using Matplotlib or NumPy, but you are by way of pandas. And lastly, it supports a number of different file formats for interacting with data files. So CSV files, comma separated value files, are probably among the most common formats that are used for storing data. That's what we're going to be using largely. And of course, in pandas, you can read CSV files easily, but you can also read in HTML, you can read Excel, HDF5, Stata, SAS, Python Pickle, and SQL files. You can read many of these different file formats directly into pandas, which is great because obviously if you want to make the jump from using Excel to using Python, it's really nice if you can directly read an Excel file in to Python using pandas. So that's kind of a teaser introduction to what pandas is. And you'll see it's a widely used library. If you Google Python pandas, you're going to find a lot of material talking about that library and how to use it. And I think probably the most logical step for us at this point is to take that step ahead and actually start using pandas and learn that way. So we'll kind of learn on the fly. And I think, Håvard, are you going to take over here maybe?
Yes, I can do that.
Then maybe I'll stop my share.
Yes. So I am going to start in Jupyter Lab. So if you want to follow along, which I recommend, then I hope you have opened CSE Notebook, and then under Notebooks and Lesson 5, we are using the Exploring Data Using Pandas notebook. So like Dave said, Pandas is a library for data analysis. And the two main data structures that Pandas uses is called data frames and series. And as you can see in the visual representation here, to the left is a Pandas data frame, which looks quite similar to Excel sheets or spreadsheets in a way, with a bunch of rows with index starting at 0, and then different columns with different column names. So in the left here is how Jupyter in the notebooks display data frames, and in standard Python programs they would be displayed in a bit simpler way. Yeah. So some of the advantages of data frames is that it looks like a table. It's easy to read, and you have the opportunity to give different column labels, for example. Yeah, and then the Pandas series is in a sense to the right here. You can see here we have index starting at 0, and then a column with all the different values. So it's basically, as you can see, it's the same values as the temp column in the data frame. So the data frame essentially consists of different Pandas series that are the columns. So columns and series I might use interchangeably here. Yeah. So in a sense, the data or the Pandas series is one-dimensional. It's just kind of like a list of all the different values, while the data frame, you have both the rows of data but also the columns. So it's a two-dimensional data structure. All right. So if we scroll down to this view, we can see we have labeled all the different aspects of the data frames and the series. We can see here, if we start to the left, we can see that there are column labels and then many rows with data in them, and then also and then an index all the way to the left. And in the Pandas series on the right, we have the same index and we have the data. And then in the object descriptions, we have the column label and the type of data that is in the series. Yeah, so you can see both the data frame and the Pandas series have indexes that can be used to select values, but they also have the column labels that are handy to identify which column you're talking about. So in this week, we'll use many of these features to explore data, and we will be using some real-world data to give a sense of how data frames work. If you want to read even more about the details of how pandas works, there's a link to a book created by one of the main authors of the pandas library, and also the documentation online, which you can go and see. But we will start with the data that we're going to use. We'll be using a text file that has weather observations from Kumpula. So that text file should be in your notebooks lesson 5 folder. Yeah. So we can, if we double click that, we can take a quick look at the contents of the data. We see there's some description on the top with some metadata, which is handy. So the data contains daily temperatures, mean, minimum, and maximum for Kumpula for a given time period. And then at the end is all the data. And as you can see here, all the values are separated by commas. So it's a comma separated values file, even though it's stored as a .txt file. But that is not a problem. So to start to get the data into pandas so we can start exploring it, first thing we need to do is to import the module pandas. So we do that by writing import pandas and then as PD, which is a common shorthand that is quite useful. So we don't have to type pandas every time, but we can write PD instead. So when we want to read in the data, pandas has a function called readcsv that is handy when we're reading CSV files. So we want to create a variable that is called data to store the data in, and then we can write pandas or PD, which is our shorthand, and then read CSV. And then within the parentheses, we need to provide the file path to our file that we're reading. So we can start with writing Kumpula, and if I press tab, then it should autocomplete. And if we press enter into that, shift enter, then we have read our data from the text file into the data variable. Yeah, so let's then check how that data looks and what is in our variable. So if you just print or type data and shift enter, we can see we get the format that is as a data frame that we saw at the top, and then we see all the different lines and different columns. But as you can see, there are something that doesn't look as it should or as we could have expected. We can see both here. It's the first column label is a weird name, and yeah, all the different columns have weird names, and then we have some weird values and some NaN values, and that might look strange, but NaN values is not a number, is what that means. So we'll get more into that later today, but yeah, but first, but we'll leave that for now, and then try to figure out how can we get this data frame to represent what we actually want to look at. So there's a question, if I can go back a bit. So if you can be a bit more specific on where, what you want me to show again, then I can do that. But basically what we've done so far is first import our pandas module that we need to use. And then we have created a variable called data and used the readcsv function of pandas to read in the data file. Yeah, and so here the name of the text file that we used, I started typing and then press the tab. But what you could also do is find your file in the file library here and press rename. Then you can select the whole file name and copy it, and don't rename it, and then paste it here. And then we get the data. All right, so I'll continue to try to clean up the data here first. And what you can see in the top here is that we have a bunch of lines that does not represent the data. So if you remember when we looked in the file itself, there are all these lines at the top that we that is nice to have, but that we don't want to be in the data frame itself. So going back to the notebook, we can scroll down here and we'll use the built-in parameter of when we are reading in a CSV file in pandas that is called skip rows. And that does basically what it sounds like. It skips the number of rows that you assign to it. So we'll again create the variable data, and then with PD we will read our CSV file that is called Coppola June, etc. And then we can give our read CSV file some parameters, and here we'll use the skip rows, and we will give it 8 as the number that we want to skip. And then we'll see if we can now print the data just to see how it looks when we print it. Yes, so when we print our data, we can see we get all the first rows that we didn't want are skipped, and it starts on index 0 here with actual values. So that is good. So there is a question about the data, so maybe Dave can take a look at that while I proceed. So as you see here, we have now printed the whole data frame, and it's but oftentimes we don't necessarily need to see the whole data set or the data frame, at least not if it's a much larger data frame than this. And one handy function that pandas has is that we can look at the only the first 5 rows of our data by using the function .head. So if we type data.head, we get only the view of the first 5 rows of data, and we can see this is read in as a proper data frame. And we can do the same thing with the built-in function tail. Then we can see the end of the data, so the last 5 rows. And if we wanted to, we could even pass this a number. So if we want the last 10 rows, we could give it tail 10, and then it outputs this. All right. So as you can see, in our data frame, we have the rows labeled with index starting from 0 going down to 29. And then we have our different columns with their labels. Year moda, which stands for year, month, and day. So here you can see the row 20 here is from 2016, and then June 21st. And then we have the temperatures, the mean temperatures, the maximum and the minimum here in Fahrenheit. All right, so then we have checked out we can see what the printout is from our data frame, but we can also, just to confirm, print type and then pass our data variable and see that we have a data frame. Okay, so yes, there was a question why we skipped the first 8 rows, the rows by 8. And then if we scroll back and up to here, we can see that there are a bunch of rows that we didn't want. And even though here it's from 0 to the row 0 to 5, then if we go into our original file, here we can see that the number of, or that our data starts at line number 9. So we want to skip the first 8 rows of that. Okay, so now we have a chance for you to check your understanding. So what we'll give you here is a few minutes to read in the data file in the same way that we've done above, but now stored in a variable called temp data. And then we only want to read in the columns year moda and temp into the new variable. So you can use this, use the use calls parameters that we can give, similar to skip rows when you read in the data. And you can also check the pandas documentation for the readcsv function if you want to. So we haven't used the use calls parameter yet, but here is a chance for you to try to find out how that works. So yes, we will get back in a few minutes, and then please use the green check marks in the Zoom reactions when you are either when you are done or feel that you have tried as much as you feel like, and then we will continue after that. All right, I think we will move on, and I will give an example of how I would do that. So we asked you to create or to read in the data file in a variable called temp data. So start by creating the variable temp data, and then do it in the same way that we did above. So with PD for pandas, and then read CSV, which is what we will want to, and then pass that the name of our file. And then we used skip rows to skip the first 8 rows of our data that were metadata. So then it comes to the use calls parameter, so which columns we want to use. So and if we just have a quick look at the pandas documentation for that, we can see here for the read CSV function, you can give it a bunch of parameters. But if we scroll down, we can see the use call parameters that we want. So here this is what kind of variable or what you can give it, and it expects a list-like or callable object. And then it returns a subset of the columns of the entire data frame. So that is what we want to do, and we want to use a list-like, pass it a list-like object. So if we go back to our notebook, then we give it a list. Let's close it there, and then the columns, the name of the columns that we wanted, and they are string format. So we want to have them in a string format, year moda. So that moda, that's the first, and then we also wanted temp. So if we run that, and then we can check the first rows of the data frame with the head function, and if we call that, we get a data frame with only 2 columns, the year moda and the temp. So the use calls is a quite handy parameter if you have a lot of columns but you only want to read in a few of them. There are several ways you can kind of select only a few columns, but if you want to do that when you read in the data, this is a very useful way to do it. Okay, I will proceed then, and we will talk a bit more about different properties that a data frame has. So here I will be using the data variable that we created above, which contains the whole data set. And one of the first things when you read data into pandas and Python, you want to explore the data set to understand it and to make sure that what you have read in is actually what you wanted to read in. So to get a bit more familiar with our data, we can check the number of rows of the data frame to get an idea of the size of it. And we can do that with the len function that we have used before. If we type the len function and then pass it data and run that, we get the length of the data, so how many rows there are, and that is indeed 30. As we saw, we had our data frame start on the index 0 and then up to 29, so that is 30 rows. So that is correct. And another way to do it is to take a look at or use the shape attribute that a data frame has. So that is also as simple as typing data.shape, and then that is we get an attribute of the data, and here we get 30, comma 4. So what the shape attribute tells us is how many rows there are in the data and then how many columns there are. So here we have 30 rows and 4 columns. So that is correct. As we saw in if we just data.head check again, we saw that this is the data frame that has the year moda, the temp, the max, and the min column. So that is four columns, and then we had 30 rows. So shape is one attribute of data frames that is handy to use. There are several more attributes that you can read more about in the documentation of pandas. But we'll check out a bit more about how we can access the different column names of our data frame to make sure those are or to get to know them. So one way to do that is we can type, as we did earlier, data.head, for example, and then we can see all the different columns. And for a small data frame, that is okay. We can see it. We can easily see them. But if there are many columns, Jupyter won't display everyone. So another way we can access which columns that are in our data frame is by accessing or calling data.columns. And so when we type that, we get the output here, that it's we get an index with the year, moda, temp, max, and min. And yeah, so that's an index object of our, which is the columns. So there was a question of why there are no brackets or parentheses after columns, and that is because columns is an attribute of the data. So the data has different attributes like the shape of it and the columns and column names. So we're not calling a function. We're not doing an operation on the data frame. We're just accessing different attributes that the data frame already has. So when accessing attributes, we don't need the parentheses. We can see if we do that, we get a type error because we're trying to call and make call a function, which we can't because .columns is just an attribute of the data. So here we get an index that contains all the different column names. And we can also type data.columns to get the attributes. And then dot values, which is in a way a sub attribute of the columns attribute. And we get an array of the different attributes, but with the same column names. Yeah, so that's a way you can access the different column names of your data frame. And another handy thing to operate on the data frame is to get to know the index of the data frame. So by typing data.index, we can get the attributes of the index of the data frame, and that again outputs range index. So it's an index in the range here that starts at 0 and stops at 30 with a step of 1. So that is similar to the range function that you've learned about previously. So as we remember, then it's the start value is where it starts, and then stop. It's not including stop. So that it's from 0 to 29 in that sense. So it's the same kind of indexing that you are used to from the lists from the previous weeks. All right. So far we have seen our columns and our index and the shape of our data frame. But if we want to know what kind of data, what types of data our data frame consists of, we can access that by the dtypes attribute. So data types. So if we go to data and .dtypes and run that cell, we can then get an overview of what kind of data our different columns consist of. So we can see that our year moda column is a integer values, while our temp, max, and min are float values or floating point values. So that is a quick way to get an overview of both the size of our data frame, what are the names of the columns are, and what type of data that's in it. So then we have come to another check your understanding part. So we would here like you to see if you can find a way that you can print out the number of columns that we have in our data frames or in our data frame. So if you can then again use the green check mark when you have succeeded to do that. That would be great, and then I'll give you just a few minutes to print the number of our columns in the data frame. Okay, I think we're at the same number of check marks as before. So I think we can continue. So as you saw earlier, one of the ways we can get more information about our data frame, we could access data.shape. Oh. Then we can see that the overall shape of the data, so both the rows and the columns. But if we wanted to just print out only the number of columns, you saw we accessed the data.columns, and we got an index. So if we and as you can see, the index here, it's a list, and we can access that by if we type the len, we get the length of the columns list, which is 4. So that is a quick way to count the number of columns in our data frame, is by using the len function that you learned about earlier. All right. Then I'll continue to a section about selecting columns from a data frame. So as you saw earlier, we when we read in a data frame, we can select at that point which columns we want to use. But if we didn't know which columns we wanted to use at that point, or if we have read in the whole data frame and done some operations on it, and then want to select only a few columns, and then we can do it in another way. So what we'll do here is we will first create a new data frame or new variable. We'll call that selection because we want to select a few columns. And we can do that by selecting, first starting with our data frame, and then for selecting values within our data frame, we use brackets. So here, and then we can pass it what we want to, the things we want to select. So what we want to do is select 2 columns here, the year moda and the temp column. And we can do that by passing it a list of the column names that we want to use. So I can make a space here just to make it clear. Then we'll pass it in, we create the list of the things we want to select. And then like we did with the use calls, we need the column names in string format. So year moda, and then pass it another variable in the, or another name of the column temp within our list. And if we press enter there, we have done that, and we can check our new selection here, and we can see we have only gotten the year moda column and the temp column, but we have all the different rows. Yeah, so we passed it, we used brackets after the data frame name to state that we want to make a selection, and then we passed it the list of the different column names. All right. So then we can see, just to make sure what type our new selection is, we can see, and we can see that this is still a data frame, or a new data frame. Yes. So, and we can also use some of the attributes that we used before. So if we pass dot shape on our selection, we can see the size of our data frame is 30 rows by 2 columns. And so that is a way to quickly check that we got the 2 columns that we wanted. And we could also another way to make a selection of the data frame. We could, for instance, if we're only interested in the temperature column, we can type data and then brackets for the selection. And then if we only want one column, we don't need to pass it a list, but we can just pass it the column. And as you see here, we get all the different temperature values from that column. And we can check by passing type the data and then temp. We can check what type the column is. And as you see, that is a series. So like we talked about in the beginning, all the different columns are series, and then when you combine the different series, you get the data frame. So when selecting only one column, we get the series, but when we select the 2 columns, we got a new data frame. All right. I hope that was clear. So if there are not any questions, I will proceed to descriptive statistics about our data frame. So when you have read in a data frame and you know that you have read it in correctly, you check the size and the column names and so on, then you maybe want to get some statistics on the data set that you have read in. So pandas, data frames in series, have a bunch of methods included that are handy for getting quick descriptive statistics. Some of them are mean, median, minimum values, and maximum values, and standard deviation. So we'll take a quick look at that to see what kind of descriptive statistics can we get out of the data frame that we've just read in. So if we want to do that for just one single column to, for instance, get the mean value or the average value of that column. So this weather data, we have 1 month of weather data, and we can see, okay, what was the average weather temperature in Kumpula for June in 2016. Then we can have our data frame, and then we want to only get the temp column, and then we want to find out the mean values. And then we pass it the function mean, and we get 59.7 degrees Fahrenheit as the mean value for June. So that's what we can do it for a single column or a series. We could also do the same thing for the entire data frame. If we just type data and pass it and call the function mean, we get the mean values here in the I don't remember what the notation is called, but we get the mean statistics for each of the different columns in our data set. So that's a quick way to do that. We could do the same thing with the other functions that are mentioned above. So we could also get the median values for for each column. Yeah. Another way to quickly get some basic statistics for the entire data frame is to use the describe function or method. So if we do data.describe and run that, we get some quick basic statistics from our data frame. So for each and then for each column, so we get the how many entries there are, how many values they are, and then the mean values, the standard deviation, and the different basic statistics that you usually get. So, and then there's a question whether the data frame in Python is the same format as R, as in the R language, data.frame. And I'm not entirely sure. I think they're pretty much similar, but I think there are some few small differences. But the concept is basically the same as I know it, but I haven't used R that much. Okay, so now there's one last check your understanding for this part. So what we want you to do now is to see if you can get some descriptive statistics for the temp, the max, and the min column. Because as you can see, the year moda column is only, or it represents the dates. So there's no really point in getting the mean value of the different dates of the month. So we want to, I want you to get some descriptive statistics for the three temperature values, the average temperature, the maximum values, and the minimum values. So please use the green check marks when you have done that. And I'll give you just a few minutes to do so. Okay, I think we're about at the same level of green check marks, which seems you get the hang of it. That was quite quick. So what we wanted to do was get some descriptive statistics for the three temperature value columns. So we could do as in the top to type each column and get some of the values. But a much faster way to do it is to use the describe method that we used before. So we start off with the data, the name of the data frame. And then if we want to select only one column, you saw that we used one bracket, but we want to pass it several columns this time. And that then it's necessary we pass it a list of the different column values. So here, then within the first brackets that are for selecting something from our data frame, then we want to select a list of columns. So we do the temp column, and we also wanted the max column and the min column. So what we've done so far here is just selected three columns from the data frame that we wanted, and then we run the describe method, and then we get the descriptive statistics for those three columns. All right, that's good. So just before we maybe take a break and I pass it on to Dave, there we will I'll go through just a few extra parts. So as part of data exploration, visualizing the data is often useful to get a visual understanding of how the data works. And we will get into more visualization in the later weeks. But one of the data frames from pandas also has a built-in function for plotting out the data. So if we have our data frame, selected the 3 columns in the same way as above, and if we then type dot plot and call that function with parentheses and run that, then it will create a simple plot of the different values of those columns. So we will get more into visualization in the later weeks, where we could customize how the plot looks, adding some labels and all that. But for now, it's just wanted to show you that by running dot plot on the data frame, you can get a quick, easy visualization of the data to inspect it. And so the last thing here, that data frames can be created from multiple sources. So as you saw, we can have different file formats, either CSV or Excel files, but we can also create data frames from, for example, lists in Python. And sometimes that is handy because you can do some operations on the data frame that are easier to do when it's a data frame than when it's a list. So, for example, by running here, we have created a variable called number series and pass it the PD for pandas and then series. And within that, we pass it a list of different values. If we just print that quick, we get a pandas series, first of all, that has a float object or type and has all the different values in a series format. So since we in our list we had the values 4, 5, 6, and 7.0, then it converted all the values into floating point values, because all the values within a series needs to be the same type, more or less. So another thing we can do, we'll be working more with different indexes later, but we could also create a custom index for our small number series. So when we create our series and pass the parameter index, we can give it a list of values of that we want the index to be. So if we run that, we can get a quick series here with instead of it going from 0 to however many rows there are, the index of this series is A, B, C, D, and it has the same values as before. So we can also check the series or check the type of the series and see indeed this is a pandas series, even though the index is different from what we are used to from before. So you can create different series, but you can also create data frames from lists. So if you remember in exercise 3, we had different lists of weather stations and their latitude and longitude coordinates. So here is just a small subset of that. So if we read in those different lists, we can then create a data frame based on those lists. If we here have our new data variable and run PD, and instead of read CSV, we here want to run the method data frame, which creates a data frame. And we can say our data in our data frame is a Python dictionary, for example. So we haven't talked that much about dictionaries, but that's another Python object. So here we the dictionary works in the curly brackets with the here. We give it the column name and then the values of that column, which here is the stations list. And then we have a new column called lat with the lats list, and the same for long. So if we create that and print out new data, you can see we get something that looks like a data frame with the station name column with the values from the list, and the same for the latitude and longitude columns and lists. And we can see that if we type new data, it is a data frame. So that is a quick way to, if you already have lists of data, you can create a new data frame and continue working on that. And it will behave just like the data frame we created before. We can print new data.shape, and we get the shape of it. And sometimes you even want to start with an empty data frame. So a way to do that is create a variable, often df for data frame is a common to use, and then pd.dataframe, and then just nothing in the parentheses, you will get an empty data frame. So here we see the it's a data frame object, which is empty. There's nothing in the columns. There's nothing in the index. And that creating an empty data frame might seem weird, but sometimes it's a handy way to have a data frame and then populate it and insert data into it, either through a for loop or through other operations in that way, and then end up with a data frame with data in it. Yes, I think that was about it for exploring data using pandas. So if there are any more questions, I can try to answer that now. If not, then I think we might need a small break before Dave continues. So if there are no more questions, then maybe we continue in about 10 minutes. So at 11:08, for instance. Yes. Okay. I see no questions at this point. So then we take a break.